So let's just look at number 2, for example. It says you're taking a vacation and you can visit as many as 5 different cities and 7 different attractions. So the attractions and cities are sort of different. Like cities is one thing, and attractions could be like a park, maybe, or an amusement park, those sorts of things. So suppose you want to visit exactly 3 different cities and 4 different attractions. How many different trips are possible? So that's your first scenario, and then it says, okay, well, suppose you want to visit at least 8 locations in general. How many would those trips be possible? So let's do the first one. So suppose you want 3 different cities and 4 different attractions. So those possible trips there's a total of 5 cities, and we're going to visit 3 of them. And so we're doing more than one thing, so we're going to multiply. There's 7 attractions, and we want to visit or choose 4 of those 7. So 5 choose 3 times 7 choose 4 would give you 350 possible trips for that combination. But what about the one where we're visiting at least 8 locations? So that's our second option. So at least 8 locations. So that means 8 or more. So at least 8 locations would mean 8 or 9 or 10 or 11. So we've got a total of 5 and 7. So we have 12 total. So that means 8 or 9 or 10 or 11 or 12 locations we could visit. So the first one would be, of those 12, visiting or choosing 8. Or, now this is the one where we're only choosing one of these combinations. We're not doing all of them. So we're going to add. So the next one would be 12, and we would visit 9 of them. Or we could visit 10 of the 12. Or we could visit 11. Or we could visit 12 of 12. So those are your possible combinations for at least 8, so 8 or more locations. So if we added all of them up, we'd end up with 794 possible trips. So you have to pay attention to the wording for these. So I want to do one more with you guys. So let's look at 3, 4, and 5. So for 3, 4, and 5, we're looking for 3 card hands. In the second part, we're looking for 5 card hands. But for 3, 4, and 5, we just want 3 cards in our hand. So the first one, number 3, says 3 black cards. Well, if we're just choosing from the black cards and we want 3 of them, we would do 26, choose 3. If you guys type that into your calculator, you would get 2,600 hands. Possible where you would just have 3 black cards. Okay, so what about 2 aces? Well, how many aces are there in a deck? 4. But this is only 2 of the 3 cards that we are going to have. So, if we need a third card, 2 of them will be aces, but that last card we are choosing can be any card from the remaining deck. So if you take 52 minus or excluding the 4 aces, that means we have 48 cards to choose that last card for our hands. So 2 and 1 are the 3 cards we need. So if we multiply 4 choose 2 times 48 choose 1, we get 288 hands. That would have 2 aces and then some other card. It doesn't necessarily specify what that third card would be. So how about 4 face cards? Well, if we're only talking about 3 card hands, then a 3 card hand with 4 cards of anything would be impossible. So this one we couldn't actually find the possible hands for, because we only want 3 cards, not 4. Okay, so you guys are trying the rest of these combination examples on your own, and don't forget to do the exercises from the book. You can find them on the page in Schoology, so you don't have to actually get the book out.